Slam Talks. We're going to do a little tag team today. We got a couple of short projects that are going to get described. I'll just remind everybody we do this every couple of weeks. We will have two speakers next week. Bill Gehring from Cognitive Psych has been doing some really interesting work where he surveys his class to death about exactly what they're doing in the class in real time because he didn't have another way to collect the data. So they actually, at this point, complete surveys every week in class about what they're up to, and he gives them credit as part of their grade for doing this. And I guess it's a cognitive psych class, so they might as well be thinking about how they're learning, right? So he's got some stuff to report about that, and Denise Sekekwaptewa will be here as well to talk about people's performance in engineering research groups when the gender mix is different in those groups. So they did some research with Laurel Meadows on North Campus about that. The week, the lecture after that, which I guess is 4 weeks from today, will be George Siemens, who is actually one of the leaders of the Society for Learning Analytics Research, the SOLAR organization, a really interesting speaker from Athabasca University in Canada. So I'll try to push that advertising out a little bit more. I'm going to start by just giving a quick reminder about what's going on with this eCoach thing since we launched it. Some of you were here when I talked about this project at the beginning of the SLAM seminar series. It was a virtual project then. It's a real project now. So what we're doing is we're using analytics and this toolkit called Computer Tailored Communication to enable us to give individualized feedback and encouragement and advice even if we have thousands of students. So we're doing this because we would like to impact STEM education. Just recently, like last week, this new report came out that went to the president from the President's Council of Advisors on Science and Technology, saying we should produce 1 million additional college graduates with degrees in STEM disciplines. All right, a 35% increase over 10 years. So there's lots of backing of this kind of thing. Nationwide, it's known that about 40% of the people who go to college intending to complete STEM majors actually do. So there's already this pool that would allow us to double the number of majors that are actually at our colleges already. If we don't drive them away from it, perhaps we can actually achieve this goal. A lot of that loss, yes?
I just wanted to ask if you knew how that is sort of spread over like community colleges.
So this is a nationwide number. In LSA, it's about 50%. Of the people who come in. It's a little hard to nail down because they express several interests when they come in, right? And they're not going to do all of them, obviously. So I think it would be a great thing for us to try to narrow down our understanding of who really is thinking they're going to be a STEM concentrator when they start. But that number's sort of 50% in LSA. It's different in engineering because once people come in engineering, they either leave the school, which very few people do at Michigan, or they graduate with a STEM degree. So the big growth area would be in LSA. Right, so there it is, right? I think that a big part of this is what happens in these introductory courses. Students come in with really different background. I would say it's a context-specific kind of diversity of background. People stand out in some contexts and not in others. They fit in some places and not in others, depending on who they are and what that context is. Almost all of our introductory courses are large, they're uniform, and they're hard. Hard in several ways. They're challenging. Students have to work hard. They're also graded more harshly than other courses on campus. And all of these things lead to attrition. Most of the people who leave STEM concentrations don't leave because they fail the classes. They leave because they get B's when they've never had anything but an A. Or because they get C's when they've never had anything but a B. They underperform, but they don't fail. So just fixing failure is not the whole thing. We think that personalization is one of the ways that we can really help with this situation. If we could go to every student and act on their background and their weaknesses, on their interests and future goals, on their status, knowing exactly where they are. If we want to do this, we want to do it accurately, we want to be careful about it, and we need to do it for everybody. So we started learning about this through this Better Than Expected project where we started measuring things like what is the correlation between incoming GPA and outgoing grade in introductory physics courses or SAT scores or age. And these are figures that I've shown before about that for a particular course here, Physics 140. Some of these incoming factors are strongly correlated with their performance, like the GPA is very strongly correlated with grade in these classes. Age is not very correlated with grade in these classes. Of course, we don't have a lot of age diversity on this campus really either. That figure you see on the top has a one-to-one line. So if a student coming in is a 3.5 student and they were expecting to get a 3.5 kind of grade in this class, they won't. We give grades in these physics courses that are lower than typical grades on campus. And this is part of that kind of sense of underperformance that students have, that they feel they're not doing as well in this as they do in other things. So this kind of field of learning analytics is about measuring, collecting, analyzing, and then reporting data about these learners and the context that they're in. And the point is to optimize learning, right? It's not just to assess things, it's actually to get in there and make the learning happen better. So here's that figure, and we think about this figure, and when we look at it, there's a lot of different features in it. First of all, you can tell that the average grade that someone is most likely to get is very strongly dependent on the kind of student they are when they arrive, on the GPA that they bring into the class. But there's more to it than that, because at any given GPA, some students do better than expected, and some students do worse than expected. And what you see on there are the means and the errors on the mean, and then the dotted lines are the 1 sigma dispersion around that. So you got some students who are doing much better than they were expected to, some students doing much worse than they were expected to. We set out to try and understand that and then act on it. What is it that makes people do better and worse than expected, and what can we do to push them toward the better than expected side?
And this is phenomenal stuff. Just how hard is it for mere mortals to do this for our own courses?
So right now it's a little hard. I'm hoping that in a year we will make data available to people so that they could do this for almost any course. I think we're going to build a layer in between faculty and what Rob has to live with, the data warehouse, right? I think that's a way to approach that. So the themes we got out of doing this kind of grade prediction was, first of all, there is this big dispersion, and we want to understand what causes that dispersion, what leads some students to do better, some students to do worse. And if we know what those strategies are, then we can help people do it. Knowing where they're coming from and where they stand and where they're headed is like, once you know that, you should do something about it. It's actionable intelligence in the lingo of learning analytics. And this eCoach project was aimed at doing something about it. Let me just skip over this. Well, no, let me say a little more about it. Once we know about this better and worse than expected thing, we can see that happening at all different places. So there are A students getting a B+, there are C students getting a B, and that relative performance really affects STEM retention. There's some nice econometric measurements of what causes people to leave STEM, and that relative performance is much more strongly predictive than their actual performance. They're just their grade, right? That relative performance compared to expectation. So we started looking into what causes better and worse than expected performance, and we did that both by doing quantitative measures of how different groups of people perform and by doing qualitative explorations of what students say leads them to perform better and worse. And the kind of things we find are not enormously surprising. Students who have really good support networks and use them well perform better than expected. Students who are first-generation students in college perform worse than expected. We can measure just how much. Students who are underrepresented in these things and experience something like stereotype threat for introductory physics, that's especially around the area of gender, underperform relative to what you would predict that they would do in these classes. And we can also see that students who are really overcommitted outside of class, suffer from that. So if we know about all these things, we ought to be able to act on them. A key thing that I want to say about this is that even the qualitative things, we could only go and ask about better and worse than expected students if we do this. Otherwise, we only know about who got an A and who got a C. But some of those C students should have got a D, and they actually did better than expected. And some of the A students really should have been A+ students, and they did kind of worse than expected. So if you don't have this, you can't even do the exploration. All right, so we created an intervention built around this Michigan tailoring system. This is something created in the School of Public Health here for creating content designed for an individual based on data about them. And the way eCoach works is they have this software framework that sits in the center. If we want to use it for this purpose, we have to first decide what would we say to people if they came and sat in front of us. So we have to gather expertise about what should you say to a person who comes in a certain circumstance. We did that by interviewing hundreds of students and dozens of instructors. We also kind of put into that some learning from behavior change experts, because it turns out it matters how you deliver these messages and not only what you say. And that was really eye-opening and helpful for us to learn about how we should say things and not just what we should say. So we had to gather the expertise and code it into the system. Then we had to collect the data, the detailed information about all of these students and their current status in the class, feed that into the system. The power of MTS is that once you do those two things, it delivers content individually to each person that you feed into the system. It says what we all agreed we would say to a student like this who came in. So the system doesn't decide what to say at all, right? I mean, we have to decide what to say. We have to invent these messages. But once you do that, it allows you to deliver those messages to each and every person. Okay? So over the last 9 months, we built a system around MTS to enable us to do this in all the large introductory physics courses. And the work we had to do was all out there. Gathering up the data about the students, pulling together the gradebook data with information about the students, figuring out what we would say to them. That's the work that had to be done in order to make this system work. Our public health colleagues did the work of building this tailoring system to make it all happen. Okay, so what do we tailor on? I should mention we're doing this in all the introductory physics courses. So there are about 2,000 students a term in those introductory physics courses, and I'll tell you about which students we're actually doing for right now. The information we gather is, first of all, knowledge about each of the courses and how they work. We know about this environment. Then there's information from the course gradebook, all of their homework scores, their in-class response, their exams, things like that. We chose for this first implementation to have students opt into the system. So all of the additional information above and beyond the course information that we have about them comes from them completing a survey. So they told us all the things that we're using. We did that because we were worried about them feeling creeped out about us knowing things about them. It turns out, I think it's pretty true, that this generation's not very creeped out about that. We probably didn't have to do that, but we did do it. What did we get from them? Well, we got detailed information about their background in science and math. We asked them about their goals and their interests, what other courses they're taking, how much they plan to work on it, what is their desired grade? It's always an A. What is their expected grade? It's not always an A. You know, there were a bunch of questions we asked about self-efficacy and confidence and how they feel, what kind of subject they feel physics is. So affect kind of questions. There are about 30 questions on this that we gathered information from them. Yes?
Plan to effort. How did you ask that? And what are you seeing with that?
So we asked them questions like, how much time per week do you expect to spend outside of class studying? And we broke it out a little bit. We said, how much time per week do you expect to spend on your homework? And how much extra time do you expect to spend preparing for each exam? So we got these kind of little categories of time. And then the first exam just happened a couple weeks ago. After that, we asked them, okay, how much time did you spend on the first exam? And, you know, we have some really interesting cases where people said, oh, I spent 2 hours getting ready for the first exam, and they did a lot worse than expected. So the very next message they get goes back to them and says, 2 hours is not enough. So it's interesting. Those.
So ask them about their what resources they're going to use and how often they'll be using those resources, like the physics helper and office hours and things like that, so we kind of have insight into how they're using it.
Right.
So the background is math and physics, and how about the other motivational engagement measures? Are they also in physics domain only? Or?
No. So their goals and interests, we want to know what are they planning to do after graduation, what concentration do they think they'll finish in. We're particularly trying to get at things like, are they pre-med students, are they engineers, do they think they're going to go to graduate school, putting them in kind of broad categories of students. That's really what we wanted that for. So who chose to do this? Okay, there are about 56% altogether of the students. Here it's broken out in a kind of funny way for engineering and non-engineering students. We did this for a presentation up in engineering. So there are two main patterns I'll just point out here. In blue there you can see that for all the students, more students in the first semester class signed up than in the second semester class. I think the second semester students just think they know how to do this already. That's not a big surprise. Overall, and everywhere in our system, female students are substantially more likely to sign up for the system and to seek other kinds of help than male students are. In those two red boxes you can see for both Physics 140 and 240, about 70% of all the female students signed up, about 45% of the male students signed up. That's part of what happened when we did it as an opt-in system like this. There are a couple other things that we found as a function of the student's GPA, the fraction of people who enrolled in the system who chose to use it. For students above about a 2.7, it's about flat, but you can see that students with the lowest performance, more of them didn't sign up, which is, of course, unfortunate. We would like to see them all sign up to use the system. So what we're thinking we'll do is in the fall, we'll probably build this into the structure of the class. So it's part of how the course communicates with every student. They'll all be part of it. They won't have to opt in this way. But at any rate, that's where we are right now. We got 900 and some students. Here's the information we got from them. I took their name off on this one. But we have all this kind of information. What's their GPA? Do they have a job? What are some things they really value? What are their future plans? This is some science and math background stuff. What kinds of standardized test scores did they have? What have they taken here already? What are they taking this semester? What are they planning on using? Like they're going to go to office hours once in a while or not. And then some affect information about attitudes. There's too much here to read, but just give an example. Here's a student who strongly agrees with the statement, nearly everyone is capable of understanding physics if they work at it. Now we have people who strongly disagree with that statement, who believe that there are people who will never understand what we're teaching in this class, no matter how much they work at it. And knowing that is interesting. So we can use that in the tailoring of messages. A couple of differences that we saw along gender lines. A question about agency. If I don't understand a scientific concept, it's usually because I didn't work on it hard enough. There's a pretty big difference between male and female answers on this question. And the confidence question, how confident are you that you can receive your desired grade, is very strongly different. So if you look at this, it's quite, 1%, 2% of the female students in this class are very confident that they can achieve their desired grade. 2%. So that's a pretty scary environment when almost nobody is very confident. Kind of amazing. Okay, so then what do we deliver to them? We give them a lot of advice about how to go about the course. We give them normative information about where they stand. We give them goal-derived motivators. So like if you're a person who wants to go to medical school, we talk about that. You have to be successful in here to go to medical school, and here's some reasons why. They get testimonials that are specific to the moment and to their identity. And we give them some data graphics. I'll show you examples of their outcomes and predicting and tracking their improvement and stuff like that. This all comes through a web page. So each student has a personalized web page with their own content on it. And we update it right now. We update it anytime significant new information arrives, like after exams. Okay, so this is just a screenshot to show you how you write such courses in the Michigan tailoring system, or how you write such content. There's some logic in here that says if you're in this class and you want to go to med school, then you get a testimonial from a student who also was in this class and wants to be a doctor, right? So you can see that it's a little complicated, but it's a tool, right? Anybody could do this. It takes a little time to learn how to use the logic and stuff like that, but it's the people in public health who built this did a great job. So we give tailored advice on all aspects of the course. It comes in the form of a bunch of accordions like this. So what should you do when you're practicing, how to practice effectively. Physics is a little different from other science classes. So when you click on these, they pop open and tell you some more stuff. I'll show you an example of that. We talk about all the pieces of the class that exist, including external resources that they might use. Here's an example of a testimonial from a student. So find out study techniques that previous students recommended. Like you, Caitlin is an engineering student. She got a great grade in her class. To study for the first exam, start early. You need to put in time to understand all the concepts, right? Whatever. These are real testimonials from real Michigan students. We use their real pictures. It should be authentic. I mean, it's not fake. So the little S's you see on the side, those all get put on whenever there's student advice coming. So definitely go through the practice exams, knowing how to do the problems. It's the same kind of stuff we would say, but it comes out of their mouths and in their kind of lingo. We tell them to prepare for the next exam. So this is what I was just talking about. You told us you spent 2 hours studying for exams. However, you didn't get the grade you wanted with this amount of studying. It looks like for exam 2, more hours are necessary to bring up that grade. Most professors recommend studying 6 to 10 hours. So this student got that because of who they were. because of what happened to them. If they'd done better than expected, it wouldn't have said that. Right. So here's a picture, just a whole bunch of the content kind of coming on, right? I'll show you more about that graphic right there. There's advice, there's research results, there's stuff about how to use your note card. In fact, the biggest mistake we made is we gave them too much information. Right? And to deliver this much information, you really have to be very careful about how you give it. So right now, we kind of have too much stuff for them. Part of the revision will be cleaning that up. Let me show you how we give them this feedback on status. So they get a plot that looks like this. They all got one of these for themselves with a grade breakdown and a grade scale on the outsides. Here's their results at the end of exam 1. They've done some homework, some classroom participation. There's the first exam score. Then we predict the other exam scores based on this one and fill up the little thing on the other side to show them where they are in terms of their grade. As the term goes on, you get more information. So the second exam is taken. Here's a person who did better on the second exam than the first. So their predicted grade is going up. If they do better on the third exam, it keeps going up. And if they do better on the final, you get this kind of better than expected outcome. So they can watch. They can track themselves and see where they're headed. We have a lot of information about this, and we're thinking about how to use more of it. And we will be giving them more graphics in the next message that will come out in a week. Mm-hmm.
I might have missed it, but what variables do you use to plug into the algorithm to predict their grades? Is it just the incoming GPA?
No, we don't do any real grade prediction. We're just looking at the grades that are in the class. So we didn't want to do anything fancy there. We could also have told them, for a person like you, we would expect you to be here. But instead, we're just using their actual scores here. Right? So this is their actual homework score, their actual, it's right out of the grade book. So this is what I would have done for a student who comes into my office. You know, I said, let's work out where you are. And then the prediction is just, okay, if you get the same exam scores you've gotten before, what will happen? It's not. We didn't want to be too fancy here. There's lots of other things we could do. We could show them where students like them are likely to end up. I mean, there's lots of, and we're thinking about doing more of that. Okay, so we're working on understanding whether this works or not. We have about half the students in the class involved, and among them, not everybody is using it heavily, so we have measures of usage. And we will look at comparing the performance of students not in the system to students in the system. And for students in the system, we will look at the impact of this as a function of activity in the system. Okay. We're especially interested in looking at these disparities based on gender and first-gen status and stuff like that. Let me just tell you a couple quick lessons. This is not really a technological problem. It's a little hard, but it's not that hard. The biggest problem is figuring out what the hell to say to all these people, because we don't usually do this. So when we went and asked faculty members about what should we say to all these people, they said everyone should work harder. That was about all the advice that they really had to give. So that's actually the most interesting and hardest part, and people could be working on that without even being involved in a system like this. Really thinking about what kinds of advice should you be giving to different kinds of students. All right. There is a future for this kind of tailored communication as an intervention engine. We're working on expanding this stuff across other disciplines, particularly across the STEM courses in LSA right now. You know, once you build a toolkit like this, there's no reason it can't be feeding messages to people anywhere in the world. So we may start collaborating with some other institutions who are gathering this kind of information about their students already. If they send it over here and we generate the message and send it back to them, why not? So we might start doing that as a way of exploring this in different contexts. So, for example, you know, a community college might be doing this kind of analytics, but not be able to give these kind of messages yet. So we're thinking about doing that. I think it'd be really interesting. Ultimately, I would love to see a tool like this that stands between the students and the university and gives them tailored content all the time for everything they do with the university. Every class, every advising session, when they're thinking about graduation, everything. Right, so maybe we'll get there. Okay. I'm going to stop because we also have Jeff Ringenberg here, and I want to make sure he gets a chance to talk about his project. Yeah, Pete.
3 comments. So when I've studied this in engineering, there's 3 things that I found to be of interest. One was just to classify all engineering students as engineering students was not the best approach.
Absolutely.
We have engineering students that there's a certain fraction, certain disciplines that they know what they want to do. And they come in and there's 80, like 90, the highest one is nuclear engineering. Somebody says they want to be a nuclear engineer, it's like 95% of those students know they want to go into nuclear engineering, they declare their first or second term, and they go on to nuclear engineering. And there's other programs, and I forget which one's on the lowest end of the list, but it's like 10% of them that ultimately do that first year. So there's this huge disparity of people that have this layer of passion to do whatever they're doing. And so for me, it would be very useful to discretize the engineering into...
Yeah, we did that. We asked them which engineering subfield they were going to work in.
So there I would, and I found disparities there. The second comment would be the other discriminator I found was just the level of experience in the first few years. So we get students that come in that are in remedial math, and then we get students that come in with 100 credit hours.
Yep.
Right? And that turned out for me to be the greatest discriminator
Sure.
in my first year courses. It's just that level of experience and maturity. There's still people in that upper category that leave the institution or fail, or and there's other people that in remedial math that do very well. And I'm sort of wondering if you could comment how you would recommend. I'm wondering how a student in remedial math is going to get certain advice, or the student that comes in with a lot of experience is going to get advice from the system.
One of the things that I like about it is you can speak to every student and tell them something that is appropriate. So for instance, the people who came in with the strongest preparation, the very first message they got said, maybe you should take Physics 160, the honors course, right? Because you're really well prepared, and that would be something more exciting and different. But that's what we did for them, though. So we did speak to them as a student who was super well prepared. We gave them advice that was relevant to them, and they might have taken it, right? If a student is a person that we feel is likely to be at risk, particularly if they're a student who has bad preparation for this but is generally a really good student, then we really want to get on them about using all the resources that are available in the class, going in and talking to the faculty member in their office hours, using the physics help room, joining a Science Learning Center study group. You know, that's about all we can do is say, you're not as well prepared as many people in this class. You just need to know that. People can be successful when they come in like that, but you know, don't think it's going to be easy for you this time.
Well, my third comment is, I give advice similar to this all the time.
Sure.
Right? And the vast majority of time, it just dissipates out one other orifice, right? It goes in and it disappears. And I've sort of decided that the best strategy is to wait for the event, that teachable moment where somebody might be receptive. So how does a student interact with this when they're teachable?
Right.
Rather than just you send it to them and say, you should be reading this.
Yeah, so one of those teachable moments is right after every exam. Right, it's a crisis moment for them. That's probably when they come to talk to you pretty often.
But is that when all the messages get generated? That's
when they get a whole new set of information every time. So their homepage says that, here's your result from the exam yesterday. It has you on a track to get a grade that is not as good as you were hoping for. Here are things we think you can do about it. So that's the main moment that we reach for. I would like it to be more interactive so the student could come to it whenever they feel they need this, but we're sort of not there yet. It's just new.
Well, if the student has a change of heart and they don't want to be a pre-med student anymore, but they want to go into environmental studies or something, is there a way to change this midstream so that...
Yeah, we survey them a little bit during the term. In the future, I think what we'll have is the whole profile will be changeable. So they'll go to their profile page and they'll just say, enter a new value anytime they want, right? That's not hard, really, for us to do.
I wonder if you notice anything about the students who you've collected information from who are offering advice in the form of feedback to the students. Is that something that once you get the right message, you can keep it forever, or are you going to have to keep updating that every couple of years to be more timely? What do you think about that?
Well, we want to build it in more or less, right? An ideal thing is to come to the end of this and say to a bunch of students, you know, you used this system, you got advice from it. What advice do you want to give to the next set of students? And can we use your image to do that, right? So to build it in, because they really know about what the system might do for them. And we know in the end whether they did better or worse than expected, and we can look at that. And we had many worse than expected students that we interviewed tell us really useful things like, you know, my big problem is I just gave up and stopped working on it. And to be able to put that testimony and say, a student said, my big problem was I just gave up and stopped working on it. You know, that ought to help someone not give up and stop working on it.
So you see that as being a dynamic piece?
I hope so.